Hi, today we're going to be learning about probability. Before we actually start, there are some things that you should probably know before watching this video. You should know about the fundamental principle of counting. That is, there are n factorial ways to order n objects in a row. You should also be familiar with things like permutations and combinations. Alright, so just make sure you're familiar with these things. If you're not, then there's plenty of resources on the internet available for you to use in order to learn those things. So permutations, combinations, the fundamental principle of counting, so you should be familiar with those things. Alright, so let's actually get started with the video. What is probability? In its purest form, probability is nothing but an indicator of the likelihood of an event. So what does this mean? Let's try to illustrate this with an example. Suppose the event that I'm talking about is, let's call it a success. So let's say, what's the likelihood of a success? A classic example would be a flip of a coin. Suppose my idea of a success is I get a heads on a flip of a fair coin. So the way we calculate the probability is we'd say, okay, so how many ways can I get a success? Well, when I flip a coin, I can either get a heads on my flip or a tails. So there's really only one way I can get a heads on one flip of a coin. And how many possible outcomes are there where, well, I can either get a heads or a tails? So there are two possible outcomes. So we say the probability, the likelihood of this success, if my success is getting a heads on a flip of a fair coin, on one flip of a fair coin, we say it's 1/2 or 0.5, or you can even say 50%. Now, something that is completely likely that has to occur only happens when our probability is 1. So if the only possible outcome was a success, then my probability of getting a success would definitely be 100%. It would be 1. So with this in mind, we can generalize. We can say, in general, the probability of getting a success is equal to the number of ways I can get a success divided by all possible outcomes. Now, if the number of ways I can get a success is the same as all possible outcomes, then it is impossible for me to not get a success. Probability of getting success is 1 or 100%, because then the numerator is equal to the denominator. My probability is 1. So now that we have a definition, let's get our feet wet and actually start by trying to answer a challenging question. So the problem we're going to attempt to solve is, if 100 coins are tossed, what is the probability that exactly 50 heads will be showing? The problem's taken from a book called 50 Hard Probability Problems by Frederick Musteller. I hope I'm saying that name correctly. So let's actually just directly apply our definition of probability to this problem and see what happens. Now, here it's really important you know about things like what 50 choose 4 and 60 choose 7 means. You should know about permutations and combinations. So the probability of heads, exactly 50 heads, is, well, the number of ways we can get 50 heads over all possible outcomes. Well, if we think about it, suppose the 100 coins are placed on a table. Imagine there are 100 coins on this table, and we number the coins 1 to 100. Okay. Now, on this table, if we want to approach it and toss all of them and get exactly 50 heads, what is the configuration that we need for our success to happen? Well, if you think about it, we actually need 50 heads and 50 tails on this table, because if we don't have 50 heads and 50 tails on this table, right, then when we flip every coin, we're not going to get exactly 50 heads. For example, if we have 90 heads and 10 tails on the table and we flip all the coins, then we're going to get 90 tails and 10 heads. We're not going to get exactly 50 heads when we flip all the coins. So this is the configuration we need in order to succeed. So how many ways can we get 50 heads? Well, that's the same thing as the number of ways this configuration can take place. If we want 50 heads, well, how many ways can 50 heads appear on this table? That's just 100 choose 50, isn't it? Because any 50 of these coins, so maybe coin number 4, coin number 100, coin number 3, any configuration of 50 coins on this table is the number of ways 50 heads could be on the table. A coin can either be heads or tails, and there are 100 different coins. So the number of possible outcomes is just 2 for the first coin times 2 for the second coin times 2 for the third coin, all the way to the 100th coin, and that's just 2 to the power 100, isn't it? So the probability should just be 100 choose 50 divided by 2 to the power 100. And that turns out to be about 0.08 or about 8%. So unexpectedly low. And the first time you see this question, intuitively you say, well, 50 coins, maybe 50%, and you'd be wrong because you have to read it. It says exactly 50 coins. The probability of it getting exactly 50 heads isn't anywhere near 50%. It's actually quite low. It's just 8%. Now, this is not the only possible question we can answer of this style. They could have equally asked, if 100 coins are tossed, what is the probability that exactly 20 heads will be showing, or 70 heads? And we'd apply the same sort of technique. What are the possible configurations of this table, such that if we approach it and flip all of them, we'd get exactly, let's say, 30 heads? Well, in that case, we need 30 tails. We need 30 tails to already be on the table, and we need 70 heads. So that when we flip everything, right, we get exactly 70 tails and our desired 30 heads. Well, how many ways are there of choosing 30 coins from this pile of 100 to have tails? Well, that's just 100 choose 30, isn't it? And divided by the total number of outcomes at 2 to the 100. And in general, the number of ways of getting exactly n heads, in general, well, you may guess now that it looks very similar. It's just 100 choose n over 2 to the power 100. That's the probability of getting n heads. Okay, that's the probability of getting n heads. And I've actually drawn, well, Wolfram Alpha has drawn a graph of the probability of getting n heads for different values of n. So we see 50. 50 actually looks like it's the highest, right? So it looks like it's the highest probability, that you have the most chance of getting exactly 50 heads. You have more chance of getting exactly 50 heads than getting 45 heads or 60 heads or 100 heads or 5 heads. And it's interesting because this graph seems symmetrical. And the reason it's symmetrical is actually quite interesting. Well, what's the number of ways of getting 40 heads? Well, we know what that is. That's 100 choose 40 over 2 to the power 100. But what's the number of ways of getting exactly 60 heads? Well, it looks like it's the same thing. Why is that? That's actually because the number of ways of choosing 60 objects from 100 is the same thing as the number of ways of choosing 40 objects from 100. Why is that? Well, if we have a table with 100 objects or coins, 1, 2, all the way to 100, and we want to pick 60 items from this, right? So we pick 60 items. These are our 60 items, and here we have a 40 items. So suppose this is 40 items. Well, every time we pick 60 items from the pile of 100, we also pick 40 items from the pile of 100. Inadvertently, because we're not picking these 40 items. We're picking these 60, but there are 40 left over. So actually, the number of ways of picking 60 items is really just the same thing as the number of ways of picking 40 items, because every time we pick 40 items, we inadvertently pick the other 60. So every time we find a unique way of picking 40 items from this pile of 100 coins, we find a unique way of picking 60 items from the pile of 100 coins. So that's why we have this nice symmetric distribution. So I hope you enjoyed the video, and I hope my attempt at introducing probability was successful and that you've learned something. Thank you for watching.